All right, strap yourselves in because today we're diving deep into one of the universe's biggest mysteries, dark energy. And we've got some fresh research to unpack, straight from the Dark Energy Spectroscopic Instrument, DESI for short.
Yeah, it's a pretty incredible project. So DSI is working on creating this crazy detailed 3D map of the universe. And the big goal, is to finally try to understand this force that makes up something like 68% of everything out there.
68%.
Yeah, and it seems to be pushing the universe to expand faster and faster all the time.
So, okay, imagine the universe is like, say, a balloon, right? Expanding. For a long time, scientists figured it would eventually slow down because of gravity, right? That makes sense.
Right.
But instead, it's doing the opposite. It's actually speeding up. And that's where this whole idea of dark energy comes in, like this invisible force that's just pushing everything apart.
Exactly. It's like this anti-gravity almost that we can't see or directly detect.
Okay, so we know it's there, but we don't know what it is.
Right. And the latest data from DSI is actually challenging some of the things we thought we knew about this force. For years, the main theory has been that dark energy is constant, like a steady engine that's just driving this expansion.
Okay, constant.
But this new research is suggesting something way more interesting. What if dark energy isn't actually constant?
Hold on, are you saying dark energy could be, what, changing? That changes everything. Tell me more about this DSI data.
Well, so DSI released its first year of data earlier this year, back in April. And the amazing thing is the precision. We're talking about measuring the expansion of the universe, and get this, with over 1% accuracy.
Wow, how do they even do that?
It's like having this cosmic ruler that can stretch across, billions of light years.
So we're seeing the history of the universe, and in this incredible detail, what's this data telling us about dark energy then?
Well, it's giving us these hints that dark energy might not be this steady force we thought it was. Instead, it could be something dynamic, something that's, evolving over time.
Wait, so the force that's pushing the universe apart, you're saying it could be changing? That's kind of blowing my mind a little bit.
I know, and this leads to some really wild possibilities. There's this model called the quintom-B model, and it proposes that dark energy's influence on the expansion of the universe is actually changing as the universe, ages.
Okay, slow down there for a second. How does this quintom-B model actually work?
Right. Imagine, let's say, a car accelerating. Instead of having a constant speed, the car keeps getting faster and faster.
Right.
Now, imagine that the rate the car is accelerating at isn't constant either. It's also changing over time. So it's not just speeding up, it's speeding up at an increasing rate.
Okay, I think I'm following.
That's kind of what the quintom-B model suggests for dark energy. It's not just pushing, it's pushing with a changing force. This model is based on something called the equation of state parameter, which basically tells us how dark energy behaves. And according to quintom-B, this parameter, it crosses this crucial threshold as the universe expands.
So the way dark energy acts on the universe isn't static. What does that mean for everything?
It means our universe might be a lot more complex and a lot weirder than we ever thought.
Okay, yeah, that's definitely weird. I'm hooked, though. Let's dive into this a little deeper. What are the implications of this?
Well, one of the big ones is that our predictions about the ultimate fate of the universe, they could be totally off.
Like the whole, will the universe keep expanding or collapse back in on itself debate? There might be new answers now.
Exactly. We used to think it was this simple choice between those two, but now, with dynamic dark energy in the picture, the future of the universe might be way more complicated. And who knows, maybe even unpredictable.
Yeah, I'm starting to feel a little nervous, but also, I have to admit, pretty excited. It feels like we're opening a whole new chapter in our understanding of the universe. So are there other theories out there trying to explain this whole dynamic dark energy idea?
Oh, there are, and some of them get pretty wild. Some scientists are even wondering if maybe, just maybe, it's our understanding of gravity itself that needs an update.
Wait, are you talking about actually modifying the laws of gravity, the stuff we all learned in school about how things fall down and all that?
Not exactly. Einstein's theory of gravity, it works incredibly well for most things. But when we start dealing with the vastness of the universe and these mysteries of dark energy, things get a little fuzzy.
So you're saying Einstein might have missed something?
He might have. Or maybe his theory just needs a little tweaking. Think of it this way. If you're playing a game, and then you discover a new rule, you have to rethink all your old strategies. Right. That's what's happening here with dark energy.
So these modified gravity theories, how do they fit into all of this?
Well, some scientists believe that instead of dark energy being this separate force, it could be that gravity itself behaves differently than we thought, especially at these really large distances.
So instead of having this invisible dark energy pushing everything apart, it could be gravity itself pulling things together in these weird ways that make it look like the universe is expanding faster.
Exactly. And the study we're looking at actually investigates three specific modified gravity theories: FR, FT, and FQ gravity.
Okay, honestly, those sound a bit over my head. What's the key thing I should understand here?
The important thing is that these theories, they offer this alternative explanation for what we're seeing with dark energy. Instead of it being this mysterious force, it could be that our understanding of gravity is, well, incomplete.
Wow, it's like we're peeling back layers of the universe and finding more questions than answers. Okay, I'm ready to keep going. Where do we go next? So we're talking about maybe rewriting the textbooks on gravity here. That's a big deal. But before we get ahead of ourselves, you mentioned these three modified gravity theories, FR, FT, and FQ. Can you give us a little more detail on those?
Sure thing. So remember how we talked about that equation of state parameter, how it basically tells us how dark energy is, acting? Well, these modified gravity theories, they're trying to explain those observations, but by actually changing how gravity works. They tweak the equations of general relativity, in specific ways to see if they can explain why the universe is expanding faster and faster.
It's like they're saying, hey, what if gravity doesn't work exactly how we thought it did, especially at these huge cosmic scales? Could that explain what we're seeing?
Yeah, exactly.
Yeah.
And the really cool thing is that this new data from DSI actually provides some support for some of these modified gravity theories.
Wait a minute. Are you saying that these theories where gravity works differently could actually be the real deal?
It's still pretty early. More research is definitely needed. But the fact that these theories can explain what DSI is seeing is, well, it's pretty intriguing. It opens up this whole new way of thinking about the universe.
So this isn't just some abstract mathematical game. These modified gravity theories could actually be describing how the universe really works.
They could be. And that's what makes this research so exciting. It's not just about confirming what we already know. It's about pushing the boundaries and exploring new possibilities.
Okay, I gotta ask then the big question. If dark energy really is dynamic and maybe even connected to modified gravity, what does that mean for, well, the ultimate fate of the universe? You mentioned that big rip idea earlier.
Yeah, that's the question, isn't it? And honestly, the answer is we don't know for sure yet. But we can say this: dynamic dark energy makes the future of the universe a lot more uncertain.
More uncertain in what way?
Well, if dark energy is changing, then how the universe expands could speed up, slow down, or even, reverse in ways we can't predict right now. It's kind of like trying to predict the weather, but millions, even billions of years from now.
So all those scenarios we've heard about, like the big rip, the big crunch, the universe expanding forever, those are all still possible.
They are. But now we've got this extra layer of complexity. Dark energy might be changing the rules of the game as the universe evolves.
Okay, that's both, terrifying and exciting all at the same time. But how can we even study something as vast and mysterious as dark energy? It's hard enough to wrap our heads around it, let alone figure out how it's going to behave in the future.
That's the amazing thing about science, though, isn't it? We're always pushing the limits of what we know and how we figure things out. And when it comes to dark energy, we're using some pretty amazing tools to try to understand it.
Like DSI.
Exactly. DSI is like this giant time machine. It lets us look back billions of years, And by mapping out where all these galaxies are, we can figure out how the universe has expanded over time.
So by looking at how galaxies are spread out, we can learn about how dark energy has been affecting things.
Yeah, it's kind of like looking at the ripples in a pond and trying to figure out what made them. And the more data we get, the clearer the picture becomes.
And DSI is not the only game in town, right? There are other projects coming up.
Oh yeah, definitely. There are all these new telescopes being built, on the ground and in space, that will give us even better views of the universe and let us study dark energy in even more detail.
Sounds like we're entering this golden age of dark energy research.
I think so. And with each new discovery, we're getting closer to solving this massive cosmic puzzle.
But for now, we've got a lot more questions than answers. And maybe that's, the mystery is part of what makes this all so fascinating, right?
Absolutely. There's something really humbling about knowing that there's so much out there that we don't understand. It keeps us curious, it keeps us exploring, and it reminds us that the journey of discovery is just as important as finding the answer.
So what's the next step on this journey? What are scientists hoping to find out next about dark energy?
One of the big questions is, has dark energy always been like this? Or is it something that, kind of emerged over time? Did it play a role in the very early universe? And how has its influence changed as the universe has grown and, evolved?
So we're not just trying to figure out what dark energy is, but also how it's changed throughout the entire history of the universe.
Yeah, exactly. And that's where these new telescopes and surveys are going to be so important. They'll let us study dark energy at different points in cosmic time, like getting a time-lapse view of how it's behaved.
Wow, that's really cool. It's like we're putting together this giant cosmic puzzle, one piece at a time. But with each new piece, the puzzle just keeps getting bigger and more complicated.
That's a great way to put it. It shows that we're still just starting to understand dark energy. There are so many questions we still have to answer, and the journey is definitely not over yet.
What about those modified gravity theories? What kind of research is happening to explore those further?
Well, scientists are building more advanced models and simulations to see if these theories can actually predict what we're observing. They're also looking for new ways to test them, to see if they really hold up under scrutiny.
So it's a combination of, theoretical work and data from observations.
Right. It's a great example of how science works.
Yeah.
We have these theoretical ideas, we test them against what we see, and then we adjust our understanding based on what we find. It's this back and forth, between theory and observation.
That's why I love these deep dives. It's a reminder that science is a process, it's a journey. And the coolest discoveries are often the ones we never saw coming. Speaking of cool discoveries, what are you most curious about personally? What keeps you up at night, wondering about dark energy?
For me, I think it's just the sheer scale of the mystery. I mean, here we are on this tiny little planet trying to understand this force that controls the destiny of the entire universe. It's both intimidating and incredibly inspiring.
I know what you mean. It makes you feel pretty small, but it also pushes us to think bigger, to push the limits of what we know.
Exactly. And who knows, maybe in our lifetime we'll see this breakthrough that changes everything we thought we knew about dark energy and the universe itself.
I'd love to see that. Okay, before we go too far down the rabbit hole, let's bring it back to our listeners for a sec. Why should they care about all of this?
That's a great question. And I think the answer is pretty straightforward. Understanding dark energy is about understanding where we fit in the grand scheme of things. It's about asking the biggest questions we can possibly ask and finding answers that could completely reshape our understanding of reality.
It's about pushing the limits of what we know as humans and exploring the unknown.
Exactly. And even if we never completely solve the puzzle of dark energy, the journey will have been worth it. Because along the way, we will have learned so much about the universe and where we fit in it all.
Well said. And with that in mind, I think it's time to move on to the final part of our deep dive. But before we do, I want to leave everyone listening with one final thought to chew on. So we've been talking about how this research, it's hinting that dark energy might not be this constant thing, that it could be changing as time goes on. And that brings us to a pretty huge question. If dark energy really is dynamic, what does that mean for the future of the universe?
That's the big one, isn't it?
Yeah.
It's the question that keeps cosmologists up at night, because it means that, the fate of the universe might not be as simple as we used to think. We could be heading towards something, a lot more interesting than we ever predicted.
Interesting is one word for it. Okay, so we've touched on a few possibilities before. The big rip, where everything just gets torn apart. The big crunch, where it all collapses back in on itself. Are those still, the main options?
They're still on the table, but dynamic dark energy throws a wrench in things. It means the universe, how it expands, it could speed up, it could slow down, it could even change direction. Stuff we just can't predict right now. It's like we thought we knew the rules of the game, but now the rules themselves might be changing as we're playing.
Hold on, so you're saying all bets are off. We have no clue what's going to happen.
Not quite. I mean, it's not like total chaos. We still have the laws of physics, and we're getting more and more data all the time. But it does mean we got to be ready for the unexpected. Our old models, they might need some serious work.
Okay, so to sum it up, we've got this huge mystery on our hands. Incredible maps of the universe, theories about how gravity might work in ways we never imagined, and on top of it all, the fate of everything is up in the air. For someone listening to all of this, what's the takeaway? Why should they care about any of this?
Well, I think there are a few reasons. First off, it's awe-inspiring, right? We're talking about these forces that shape the whole universe.
Yeah.
It's bigger than any of us can even wrap our heads around.
I'll say, it kind of makes our everyday problems seem pretty small, doesn't it?
Oh, for sure. But it's not just about feeling small. It's about pushing the boundaries of what we know as humans. We're asking these fundamental questions. Where did we come from? What are we doing here? What even is reality?
And those are questions we all ask ourselves at some point, right? I mean, we're all part of this whole cosmic story, whether we realize it or not.
Absolutely. And this research, it's a testament to how clever humans are and our need to figure things out. We're building these amazing instruments, coming up with complex theories, and always questioning what we thought we knew.
It's like we're explorers, always pushing the boundaries of knowledge, no matter how far we have to go. And even if we never find all the answers, even the journey itself is amazing.
You said it. It's all about the journey. The curiosity, the questions, working together to figure things out. That's what pushes science forward, and at the end of the day, that's what makes us human.
And on that note, I think it's time to wrap up this deep dive into the mysteries of dark energy. We've covered a lot of ground today, from mind-blowing maps to some seriously weird theories. And hopefully we've given you a lot to think about.
Yeah, if there's just one thing to remember from all of this, is that the universe is stranger and more amazing than we ever thought. And we're really just getting started figuring all of this stuff out.
So to everyone listening out there, keep looking up, keep asking those big questions, and never stop exploring all the mysteries out there. Who knows what we'll discover next?
Until next time, keep those minds open and keep exploring.